Okay, so I apparently need to explain to some people how circles work. Um, yeah. So, let's see what the top of this is visible. Okay. So here we have a circle. There's the center of it, and this could be something like a crank in an engine. And so if we're considering it that way, then up here, that will be top dead center. Alright, now say we have an engine where we get all four strokes in a single rotation of the crank. Okay. The easiest way, I think the simplest, probably first way to think about this would be we have four strokes, so we might as well try to put them into 90-degree segments each. Okay, that's not going to work very well for the power stroke because it's not going to deliver a whole lot of power. You want to be able to get a decent amount of the way down here, right? Anybody familiar with engines, so you're going to be like, okay, yeah, that's what we want. Okay, so we're going to want to take the power stroke from TDC to somewhere down in this area here. So, sure, there we go. Now we have three other strokes to worry about. um, because we're moving air around, we kind of don't want to do it too quick. So it's, like we don't want to try to fit a whole stroke in like just a few degrees here, right? Where we got this power stroke here. We don't, we want to divide it fairly evenly, something like that. All right. So let's say this was 120 degrees for your power stroke. All right. Now we have some weird mechanism where the crown of the piston, whatever, is able to close and move up separately from the body of the piston that's attached to the crank. It has to get all the way back up by this time. Let's say this is 200. Okay? And then it has to get all the way back down for the intake, but because we cut up this space relatively evenly, um, I can't come all the way down 120 degrees because there just isn't time. So say this is 265. So we still come pretty quickly with the intake, but we can't come this full distance here. And then the compression stroke is here. Now, and this is governed by the main piston moving around, right? This height right here, we can see these heights are different. Squiggly lines, okay. Right. This height of the intake and exhaust is smaller than this height of the, or no, intake and compression of the power and exhaust, right? The intake and the compression are tied to each other. They have the same bottom. The power and exhaust are tied to each other. They have the same bottom. These two, in this setup, these two are not tied to each other. In a conventional four-stroke engine, you get a full TDC to bottom. You get that full motion in one way or the other for each stroke, so every stroke is the same distance. Here, the intake stroke is shorter than the power stroke, so the volume because presumably the diameter of your bore and the whatever isn't changing. The only thing that's changing between these is that distance, the stroke distance, that length, so the volume of this intake is less than the volume of the power stroke. Which basically means that whatever air and fuel you can bring in, when you burn it, it's going to push less efficiently over here. I feel like that's relatively important. I also think it's ridiculously obvious when you look at this sort of, this would be a D cycle. When you look at this sort of arrangement, apparently it is not obvious to everyone, but oh well.